I did not get to grading those yesterday. That's probably for the better. So what we're going to do is go over the A version. I'm not going over the B version because it would just be way too long. But I'll put the B version answer up after we talk about this one. And just so you know, I gave everybody 100 because I didn't get to grading it, but I wanted the grade entered, so you all got 100. And then I didn't have the energy to even put a no count if you were absent. So if you're absent, so you got 100 for being absent. So Merry Christmas. And I just recorded for posterity my entire Slack record, the whole story. Okay, so what we have here is a standard form polynomial equation that we're going to graph. We're going to begin by talking about end behavior. What's the first thing we think about when we're determining end behavior? What about the A value? Positive or negative? In this case, it is positive. So when A is positive, so positive A means what? What does that determine? The right end behavior. And so positive A means the right end behavior is up. And then what's the second thing we need to think about? The degree. What do we care about the degree? Whether it's even or odd. So this is your A. This is your degree. This degree is even. So what's true about end behaviors for even degrees? Same. So then the end behavior for this particular function is up, up. Okay, good. I forget the music every class. Y-intercept. Y-intercept means you let x equal 0, because it's where it crosses the y-axis, and x equals 0 everywhere there. This is what you're going to do whether it's in standard form or factored form. This one is in standard form. It's the easier one. You basically just imagine all the x terms dropping off because they're 0, and then you're just left with the constant term of negative 48. So the y-intercept is 0, negative 48. And that's a crazy number. Yesterday I told you just draw it off the graph somewhere, like down. It's not going to be to scale. So far we have this information. What we need next is zeros. Again, if you have standard form, there's one on your review or on your test. I'm sorry, if you have factored form like this is an example. It's real easy to tell what the zeros are, right? This would be 5, and this would be negative 4. But we don't have that. We have to find that for ourselves here, and what's our process for that? Synthetic division, right? Testing out zeros. So usually we just start with 1 and negative 1, but this problem gave us the starting place. It said that factor is x minus 3. So what information do we take from that to start our synthetic division? What number do we put here? Positive 3. And then you take all your coefficients, 1, 5, negative 4. Oh my goodness, that's a lot of numbers. Okay. Do your math. Math ensues. And you have a remainder of 0, which we were already expecting. Okay. Now, when you see 4 numbers, you should try what? You should try grouping. Yesterday, I wanted to save some time when I told you grouping is not going to work here. So you have to do another round of synthetic division. And what numbers did I tell you to try yesterday? 2 and negative 2. For version A, which one worked? Negative 2? Okay. So when you do your second round of synthetic division, you use these new numbers, not your original ones. Bless you. And then when you get down to 3 terms, what factoring method do you do? cross method. So what multiplies to 8 and adds to 6, 4 and 2, divide by the a value, doesn't change anything here because a is 1. So here's something you need to bring to your attention. When you're writing factors from the cross method, don't change the sign. Don't change the sign here. When you're writing factors from the zeros, you do change the sign. So don't change the sign. Yes, change the sign. So from here, your factors are x plus 4, x plus 2. From the cross method, okay. From this 0, negative 2, your factor is x plus 2. And from this 0, 3, your factor is x minus 3. So here's your factored form. If you were to FOIL that craziness out, you'd get the original function. Okay. I'll take this form right here or this form. Whichever you like. So now we've got those. We take the zeros from them. This 0 is negative 4, this one negative 2, this one positive 3, and you can graph those up here. Negative 4, negative 2, and 3. To figure out how the graph behaves at those points, you need to know the multiplicity, whether that's even or odd. Please remember about that word multiplicity. It's like multiples. How many multiples are there? I'm not asking you, I'm not, N-O-T, not, this is bad, if these numbers are even or odd. Like, I don't care if negative 4 is even or odd, or if 3 is odd. I care about how many times their factors occurred. So how many times did x plus 4 occur? 1 time. This is the number I care about. Is that number even or odd? And what is it here? 1 is odd. So because the multiplicity of that factor is odd, the behavior at the point is that the graph is going to cross through the x-axis. How many times did this factor x plus 2 occur? How many? Twice. Now, I know there's lots of 2's everywhere, but this is the one I care about. That is even. And so when the graph gets to that point, negative 2, it will bounce and go the other direction instead of crossing through and keeping on. And then 3 is the same. The multiplicity of x minus 3 is 1, which is mod, which means it's going to cross through. So here's what we've got going on so far. We know that the graph crosses through negative 4, and because we know it's going up on the left forever, it's going like this on that side. I don't know what's doing down below, but I know at least that much. Same thing for the right-hand side. For this right 0, since it's going up forever, I know it's going to cross through because I know it doesn't bounce there. Some other stuff I can already deduce is if it bounces at negative 2, and I know it's going to be coming from below because it's passing through here, I know it's got to bounce here. Here are the things that I don't know. I don't know what the graph is going to be doing between each set of points. Like, there's options. Maybe it goes like this. I didn't want to do that in blue. Maybe it turns here or way down here. So what we have to do to figure that out is do a test point in between them. So what's a good number between these two zeros to get a point for? Negative 3. So we'll get a point for x equals negative 3. Same thing between the negative 2 and the y-intercept. It could go straight through the y-intercept. It could dip below. It could just come right at it. So we want a test point between these two. I think negative 1's good. And technically, you should also do a test point between here and here. But to my mind, I don't really care so much because it's not going to be turning there. I know it's going to be going through here somewhere and on up into positive infinity. But if you did one there, that's good too. Like I'm not gonna, that doesn't make it bad. It just makes it actually better because you have more information. So to get those mid-interval points, you can take the negative 3. You need a y to go with it. So you can take that negative 3, plug it into all these x's. Plug it into all of these, fourth it, cube it, square it, times this, and do all that math. That's not a problem. However, it is tedious with those baby calculators. I don't recommend that process. I think you should do synthetic division. Because what part of synthetic division gives you the y value? The remainder. So let's do synthetic division with negative 3. And I don't remember the numbers. Let's see if I can memorize them. 1, 5, negative 4, negative 1. Okay, I'm going to forget. 1, 5, negative 4. I had to write them super fast. I got them right? Okay. You do your math, 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 math. Blah, blah, blah. Etc., etc., etc. More, more, more. I did something wrong. 2, negative 6, negative 10, 30, negative 16. Ah. Correct math ensues. All right, we have that. That's not right either, is it? What did I do? What did I do? And negative 3 is not a 0, is it? Did I get these numbers right? Oh, no. I don't think so. What? 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 Here? Ah, thank you. Y'all are so kind. Excuse me, what? And that's what I'm asking. So then we have this point right here, negative 3, negative 6. All right, so I'm going to put that on my graph. I don't want to do synthetic division on this one because I'm sure we're all done with this problem. I happen to have that one memorized because I've already done this lesson 3 times today. If you did negative 1, you'd get negative 12, which is here-ish. So then we've got, wait, I feel like I did something wrong. Oh, no, I had to do this, sorry. I'll tell y'all what. There we go. Yes? Questions about that problem? All right, if you did version B, I'm going to put it up here. Your answers on your test review are on the back. I also have the solutions, like I did the work. That's on my desk. I will also put it in Google Classroom later, but you're welcome to take pictures of it. You have the rest of class to work on your test review. Please ask me questions.